Hello students, welcome back. By popular demand, today's session focuses entirely on reagents. We are going to break down more than 20 essential reagents using just one comprehensive question. This is the perfect quick revision for your upcoming exam. So let's dive right in. So what is the final product when benzene undergoes series of reactions? When benzene is treated with ethanol chloride and acid chloride in presence of a catalyst, what will be the product? Acetophenone, because this is a Friedel Craft acylation, hence the product will be a ketone. This is a classic example of electrophilic substitution reactions of the aromatic molecules. Then it is treated with bromine in presence of iron, which is a catalyst here. This will again undergo electrophilic substitution, and where the bromonium ion should get directed towards meta position. How do you know this? By identifying the group present on the benzene. This is a minus R group. That is, it is withdrawing electrons through resonance. Hence, it is meta-directing group. Therefore, you are going to get meta-bromoacetophenone. And the bromination happens only once. Many students get confused whether it happens once, twice, or thrice. I'll give you a hint here. If there is an electron withdrawing group, it deactivates benzene ring. Therefore, bromination happens only once. The metabromoacetophenone is further reacted with a diol. It's a vicinal diol, also called as ethylene glycol, in presence of a catalyst. CAT stands for catalyst, and it is acidic in nature. It's a tosyl hydroxide. That means what? Few drops of the acid with the glycol means what? The ketone reacts with the diol to form a ketal. And this is having two hydroxyl groups within the molecule. Therefore, what happens? It's going to form a cyclic ketal. And what is this cyclic ketal? It is a 5-membered ether. Like this, you can write the structure of the molecule. The bromine is not changed. You can write down that as it is. So this is our product after using the third reagent. Then what is done here? It is treated with magnesium in ether. The moment you see this reaction condition, it should strike your mind that it is a method to prepare the Grignard reagent by inserting magnesium between this carbon and bromine. Therefore, you are going to get the Grignard reagent. And this is the structure of the Grignard reagent formed. Then what is done here? Look at this H2CO. If you don't understand, try to elaborate the molecule. You see, this is nothing but formaldehyde. Whenever we have a Grignard reagent and aldehyde, the aldehyde will undergo addition reaction like this. So that is the reason we are protecting. So why we are forming a cyclic ketal here? So that we will protect the ketone group. And now we are doing addition reaction. And what sort of product will be formed? We are going to get like this. So the carbon-carbon bond formation will happen. The two hydrogens are as it is. And then we have OMGBr like this. What is done after this? You can see that it is treated with aqueous ammonium chloride, and there is a hint here, quench. What do you mean by quench? We are getting rid of this MgBr. So it is done in basic conditions because we have to still retain this ketal part, right? That is the reason it is done in basic medium, and all you have to do is replace this MgBr by the hydrogen. That's it. First, Grignard reaction, and the formed salt is treated with aqueous ammonium chloride so that you are getting the corresponding primary alcohol. So we can write this in one step itself. Now let's see what is done after this. The seventh reagent is PCC in dichloromethane. This is a popular oxidizing agent used to convert a primary alcohol to an aldehyde. So this group will remain as it is, and you can see that this will get oxidized to aldehyde like this. Once you get the aldehyde, you're treating it with organolithium compound in tetrahydrofuran. THF refers to tetrahydrofuran. It's a aprotic polar solvent mostly used with the organic compounds. So what sort of reaction should happen? It will undergo addition reaction because you see, we are using somewhat a strong organometallic compound. The lithium will have plus charge and the carbon here will have minus charge. So like this, it acts as a nucleophile and it will attack this carbonyl carbon. So it will undergo addition reaction, and you see the double bond will become single bond, which will be balanced by the lithium ion. And what is happening to the isopropyl? It is attacking over here. So this is our product after treating it with organolithium compound. And you see again we are quenching this. As I told you earlier, the inorganic part, whatever we have, MgBr, lithium, all of these, if you have to get rid of, just use the aqueous ammonium chloride and you are going to get the corresponding alcohol. This is a product after doing the ninth reaction. Now this molecule is treated with an oxidizing reagent PDC in dichloromethane. PDC refers to pyridinium dichromate and it's an oxidizing reagent. It will oxidize the given secondary alcohol to ketone. So this is the ketone we are going to get, and this cyclic ether will remain as it is because ethers are not susceptible to undergo oxidation. So this is the 10th reaction. It is treated with Grignard reagent. Grignard reagent, here it is acting as a nucleophile because there is a carbonyl carbon, it attacks it and it will undergo further addition. And then what happens? When ketones react with the Grignard reagent, we are going to get a tertiary alcohol. Remember, as I told earlier, whenever you have quenching condition, what happens? Immediately it will form an alcohol. The isopropyl will remain as it is, and this is where the pH will be present, and the cyclic ether will also remain as it is. So this funny looking molecule we are going to get after the 12th reaction. So now we are going to treat this with sodium hydride. So what is the function of sodium hydride? Sodium hydride acts as a base. That means if there is any acidic proton, it's going to abstract it. Where is the acidic proton? Tertiary alcohols are acidic in nature. Therefore, the hydride is going to abstract the proton here and it's going to form the sodium salt of the alkoxide. Why do we do this generally? In order to form a better nucleophile. How do I know this? Look at this. After sodium hydride and ether, you have an electrophile. The carbon present here will be electrophilic. That's the reason I know that we have to generate a nucleophile. And what is the electrophile? Benzyl bromide. You see, it will undergo nucleophilic substitution reaction like this. The bromine will leave the molecule. So what sort of product are we going to get? Ether. So this is nothing but Williamson ether synthesis, a named reaction. The formed alkoxide is forming an ether. By looking at the next reaction conditions, you can tell that the ketal is undergoing hydrolysis. How so? Whenever we have ketals, they are very susceptible to undergo hydrolysis in acidic medium. So when we add 5% of HCl and stir it for 3 hours at room temperature, the molecule will get cleaved over here and we will get back the ketone. See, here further we will not be doing any reaction. So what I'll do is I'll simply write this bulky group as R. It's not undergoing any reaction here. That's why I'll simply write this group as R, because further the reactions will be happening with respect to this ketone. That is the reason. After hydrolysis, what will be the next reaction condition? Sodium borohydride. This is a reducing reagent. Sodium borohydride in methanol selectively reduces the ketone to alcohol. Since it is a ketone, we are going to get a secondary alcohol like this. Okay. What will be the 17th reagent? This is a nucleophilic substitution reaction. So we can do it directly here. The OH will be replaced by bromine. All these reactions are pretty simple. So we can do it here itself. Okay. So after 17th reaction, you are going to get the halo product. And then 18th reagent. What is this reaction condition? Sodium methoxide in methanol means this is alcoholic base. Therefore, you have to do the dehydrohalogenation and you are going to get a vinyl product like this. Like this. The double bond will be formed. Dehydrohalogenation. And then the double bond is reacted with MCPBA. There is a ketone, we get the ester, but this is a double bond, isn't it? Therefore, you are going to get the epoxide. So alkene can be converted to a cyclic ether, nothing but epoxide, when we treat it with metachloroperbenzoic acid in DCM. So this is the product we get after the 19th reaction. Now let's make some space here and then write the next reactions. I have elaborated the structure of the product epoxide what we got here, and then we are going to treat this with Grignard reagent. Again a nucleophile here because there is highly strained molecule. There is a ring over here which can open up easily. The phenyl will attack from the less sterically hindered side and it will open up the epoxide. And then what we'll do, again as I told you earlier, it will quench the reaction mixture to get rid of the MgBr. So what will be the structure of the final product after the last reagent? What will be the structure of the product? The OMgBr will become OH, right? The CH2 is attached to phenyl. And what about here? This carbon is attached to phenyl and isopropyl and an ether like this. So this is the final structure of our product. I have an additional question for you. Can you find out how many chiral carbons are there in the final product? So please let me know your answer in the comment box and don't forget to solve the question I have included in this video. Thank you for watching. Until next time.